All right, this is the second half of our Chapter 2 review. So we're going to start with Section 2.4. This was on deductive reasoning, and we used the law of detachment and the law of syllogism. The law of detachment said that we match the hypothesis. We are given an if-then statement, a conditional, and a second statement has to match the hypothesis, and then we assume that the same conclusion is true. And the law of syllogism said that we were given two conditionals, so we can write two conditionals here and one conditional here. And for the law of syllogism, the conclusion of one of them had to match the hypothesis of the other, and then we could just cut out the middleman there and combine our leftover hypothesis and conclusion. So let's get to these. First one says, if two angles are vertical, then they are congruent. Angles 3 and 4 are vertical angles. So let's use our colors. So our requirement, if two angles are vertical, then they are congruent. Okay, we have two separate ideas there. And now our statement here says angles 3 and 4 are vertical angles. Does that match one of what we have? Yes, it does. It matches our blue one here. So here we have a single conditional and a second statement that matches the hypothesis. So we can say that angle 3 and angle 4 are congruent because we matched our hypothesis. We can assume that the same conclusion will be true, and that is by the law of detachment. That almost says detachment. All right, let's look at the next one. We have if a number is divisible by 12, so that's our first thought, then it is divisible by 6. That's a new idea, so we give it a new color. And we have 24 is divisible by 12. Well, that matches our blue statement. So I see a law of detachment there, but we have more stuff going on. So this one says if a number is divisible by 6, I've seen that somewhere before. That's this statement up here. Then it is divisible by 3. That is a completely new statement. So we give it a new color. All right, it looks like we have a law of detachment that we could use with our 24 is divisible by 12. That is a number divisible by 12. And we also have a law of syllogism that we can use. So it doesn't matter which direction that we use these. So I'm just going to say that these two match and they cross out. And we're going to write an entirely new statement here that says if a number is divisible by 12, then it is divisible by 3. And we're going to go with some new colors. So if a number is divisible by 12, that was our blue statement, dark blue statement here, then it is divisible by 3. That is our new idea. This was law of syllogism. So now we can match this other statement over here, 24 is divisible by 12, to our beginning statement here, our hypothesis. Our hypotheses match. So now we can write our hypotheses match. So 24, that is a number, 24 is divisible by 3, because our new conclusion here, if our hypotheses match, then we can assume, or we can make, we don't like to assume, we can make the same conclusion. So that's the law of detachment. All right. The last one here. If a figure is a square, okay, that's an idea, so we give it a color, then the figure is a parallelogram. All right. Next statement says, if a figure is a rectangle, well, that doesn't match anybody, so we have to give it a new color. Then the figure is a parallelogram. Well, that matches our green one up here, so we're going to give it a green one. We don't have a statement. None of the statements match the hypothesis, and we have two conditionals, but we have two conclusions that match. So instead of a conclusion and a hypothesis, we can't make a conclusion on this one. So there's no conclusion that can be made. None of our requirements are met. None of the rules are followed. We can't do anything with that one. Okay. Those were fun. 2.5. Oh, we started proofs in 2.5. Those were fun. So what are we doing first? This says, name the property of equality or congruence that justifies going from the first statement to the second statement. I like these. All right, the first one here says segment AB is congruent to segment AB. We know that one as the reflexive property of congruence. We're talking about segments are congruent, so it's the property of congruence. All right, the next one, segment PQ is congruent to segment RS, and segment RS is congruent to segment TU. Oh, do you see it? Do you see it here and here? And segment PQ is congruent to segment TU. That is our transitive property of congruence. Transitive property is one of our favorites. Anytime you see these two matching things, you know it's either substitution or transitive, and this one is transitive because we are matching up, or kind of mashing together two separate ideas. All right, what do we have next? 5x equals 10 turns into 10 equals 5x. All we did was switch those around. Switch sides. That's the symmetric property of equality there. All right, and the last one on this line, measure of angle 1 equals measure of angle 2. Measure of angle 2 equals 180 degrees. Look here, do you see them in the middle? So the measure of angle 1 equals 180 degrees. Now we see these two matching in the middle, and we might think transitive property, but look here. What are we doing? We are simply substituting, right? Instead of taking these two out of the middle there, we are saying that the measure of angle 2, don't want to erase that, the measure of angle 2 is 180 degrees. So anywhere I see measure of angle 2, I can simply substitution property. I can simply substitute 180 in for wherever I see angle 2. Now remember, I said I'll be very generous with the transitive property and the substitution property, but these are two very good examples of transitive property is two separate ideas that we are bringing together, kind of like very similar to the law of syllogism. And substitution property is where we are replacing, most often, a number. We're simply replacing measure of angle 2 with the 180 degrees. All right, next row. Angle M is congruent to angle N, and angle N is congruent to angle M. Well, that's just symmetric property. only this time it's of congruence. Don't forget that. All right, and then we have 7x plus 3 equals 24. And how do we get to 7x equals 21? Well, we just subtracted 3 from each side, so that's the subtraction property, and don't forget of equality. All right, next one. 5x plus 3x equals 24 turns into 8x. Well, we are simply combining like terms, which we know to be the distributive property. Distributive property is the same thing as combining like terms. And the last one here, length RS equals length ST, and length ST equals length TU. Using proper terminology is really useful here. Do you see it? I see transitive property. How do we know that it's not substitution? Because these are two separate ideas. This is the transitive property, and this time it's of equality. So those are good. If you can recognize those, everything's good. All right, we have a proof. Okay, first thing I'm going to do is look at my diagram. I've got a big angle, and it's made up of two smaller angles. So I'm immediately starting to think, well, maybe angle addition postulate, maybe something else. Let's look and see what we are given. We are told that ray PF, so let's go find ray PF. I see it there right in the middle. Do you see ray PF? And I'm told that it bisects, so I immediately write 2 congruent. It bisects angle EPG. So I find angle EPG, and what does that let me do? It lets me mark those congruent. And so that's definition of bisect. We use our ideal here. Definition of bisect gives me 2 congruent parts. And then I want to prove that x equals 6. So x equals 6, I'm probably going to need a definition of congruence to make my measures equal, right? And then I'm probably going to use substitution, and I bet my properties of equality. That's my guess. That's how we get to an x equals 6. Okay, well, now we have our ideas over here. Let's turn them into a proof. Now, the first step of every proof is we write our given. So we could put number 1 here. Ray PF bisects angle EPG. So number 1 over here, that is a given. So we know that. You have to have that in there. Now, step 2, I am going to say that angle EPF is congruent to angle GPF, right? That's just my 2 angles there. And what lets me say that? That's just definition of bisect. Oh, let's do this properly. Some of you are already doing this. You got smiley faces for it. Definition of angle bisector. Yep, because we have segment bisectors and angle bisectors. So we should be proper. And that should look more like angle. All right, our next step. Well, that's not going to let me put my numbers in. So my next step needs to be that the measure of angle EPF is equal to the measure of angle GPF. And what lets me do that? That's just the definition of congruence. Congruence means equal. Congruent angles have equal measure. So that has let me write that. Now, why do I want to do that? Well, step 4 is going to let me say that 4x plus 2 equals 6x minus 10, and that is simply the substitution property. All right, now what's my next step going to be? I am going to subtract 4x from both sides. So step 5 is going to be 2 equals 2x minus 10. And what let me do that? The subtraction property of equality. And then what am I going to do next? Well, I'm going to add 10 to both sides. So that is going to give me 12 equals 2x. And what let me say that? The addition property of equality. Notice I can shorten addition property of equality, but subtraction property, we could probably take off the ION if we wanted to shorten it. But you need to be very careful that if you're shortening these, that you show the difference between substitution property and subtraction property of equality. So make sure I can tell which one you're using. You know I like shortening things and don't mind it, as long as we do it appropriately. All right, next step. What are we doing next? Well, I think I'm going to divide by 2 on both sides. So that is going to give me 6 equals x. And what let me say that? The division property of equality. And we have proven what we were asked to prove, that x equals 6. If we wanted to be truly appropriate here, try this one on for size. Step 8, x equals 6. What lets me say that? That is the symmetric property of equality, right? Because I said 6 equals x, and we were asked to prove x equals 6. Now, you could have subtracted 6x from both sides, and then subtracted 2 from both sides, and then divided by -2, and you would have ended up with the exact same thing. In geometry, thank you, geometry, for having 27 different ways to solve the same problem. So your answer may still be correct. That's what our look back and learn is section of the ideal is for, is to look and see if we have set everything up in the best way possible. All right, we've got another proof here. Yay! Everybody loves proofs. All right, what are we given? We are given that length AC equals length BD. So let's go to our diagram. Length AC is that, and length BD is that. So I am thinking immediately that we might be using the reflexive property of equality there for BC. BC is BC. And it's looking to me like, let's see, what do we want to prove? We want to prove that this length equals this length. Well, how do you think we might go about that? I am seeing a bit of the segment addition postulate, right? Because piece plus piece equals whole, which just by math means whole minus piece 1 equals piece 2. So that's still segment addition postulate. I think that's all we're really going to use. We don't need anything to be congruent. We just need them to be equal. So let's try to figure out how to set this up. So let's look at this logically. We know that step number 1 is length AC equals length BD, and that is a given. All right, well, what can we do about AC? Well, you know what? How do I make AC? AC is AB plus BC. That should have been blue, because it's blue up there. AC is AB plus BC. Length AC equals length AB plus length BC. And length BD, notice how I'm keeping everything in the same order as in my given. Length BD equals, and I'm actually making some choices here. I'm going to want to put my plus BC down here on the end. So CD plus BC. Why do I want my BC on the end? Because I want it to remind me that I've got the reflexive property here. So that's my segment addition postulate. How am I going to put that into my proof? Well, just like it says, we can use that for step 2, and we can say that length AC, AB plus BC, and length BD, CD plus BC. And what lets us say that? That's the segment addition postulate. And we could just use it once. It works for both of our lines here. Okay. Now, what are we going to want to do? Well, we're going to want to be able to do something with our BC here. Like maybe subtract it off, or something along those lines. We should probably put this in now. Length of BC equals length of BC, just to get it in there before we decide to use it. That's our reflexive property of congruence. There's many ways to approach this, but it's all going to end up being the same thing. So now I know that AC here and BD here, I have stuff that I can substitute in for those, right? I know that AC can be written as AB plus BC, and I can say that that equals BD. Well, what can I put in for BD? CD plus BC. And step 4, let's make step 4 green. Step 4 is just substitution. Right? Because I have my given, and then I said AC is these two pieces added together, so I can just substitute it in there. I am just substituting in for AC equals BD from my given. Okay? Now what do I want to do? I'm going to subtract the length of BC from both sides. And I can do that. Right? So what does that leave me with? The length of AB equals the length of CD. And what let me do that? The subtraction property of equality. Because the length of BC is just a number. And look, I ended up with what I wanted to prove. So you have to think your way through these, and order can be changed. So I promise you, you will get better at these. Use the ideal method, do all of your thinking over here, and then once you go to set it up, you can, look over at your notes and figure out how to get to what you want. All right, 2.6, before things get too long here. Proving angles are congruent. All right, we want to find the value of x. Well, what do you see right here? I see the vertical angle theorem tells me that those two are equal. Right, those two are congruent, so I can say 3x minus 14 equals 2x plus 10. And I'm just going to go through this in the interest of time. So x minus 14 equals 10, add 14 to both sides. So x equals 24. And what do we see here? Oh, look at that. This is definition of complementary. And what does that tell us? That tells us that 2x plus 4x is going to equal 90. So 6x equals 90. Divide by 6. What does that go in? 15 times? So x equals 15. Oh, and what do we see here at the end? One of our favorites. I see the linear pair postulate. Do you see it as well? I see a line, linear pair postulate. And what does that tell us? That tells us that 2x plus 5x plus 5 is 180. So 7x equals 180. 7x equals 175. Divide by 7. X equals, that goes in there twice, 35. What is that, 5? Yeah, that's 5. Yeah, 175. It's going to be 25. Of course, look at that. 175, you've got 4 of them to get to 100, and then 3 more to get to 75. Of course, x is 25. All right. Those are fun. We enjoy those. And our last problem here is a proof. We love proofs. We can do this. Let's see what we're given. Let's look. We've got 3 angles here. Oh, good, and they're numbered. That is so much easier than letters. But we got to be good at writing letters too. We are given that angle 1 and angle 2 are complementary. So I know this plus this equals 90 degrees, right? Complementary. And I am given that angle 2 and angle 3 are complementary. So this plus this also equals 90 degrees. Very interesting. And I want to prove that angle 1 is congruent to angle 3. So that is my goal right there, that those are congruent. I believe that we are proving one of our theorems. Go check out the theorems that we learned in 2.6. I bet you will recognize it. Possibly the congruent complements theorem. All right, well, let's take a look at these. I know that the measure of angle 1 plus the measure of angle 2 equals 90. That's just definition of complementary, right? We're given that over there. They're complementary. And I know the measure of angle 2 plus the measure of angle 3. I am going to make a conscious decision here to write it that way. How come I did that? Keep my angle 2's together. This right here shows me reflexive. That looks like a reflexive property to me. Or look right here. Maybe a transitive property. I think we could probably do this both ways. And I think that's all we have. We're adding them together. I think we can do this. All right. in the interest of space, and you do not get to do this, angle 1 and angle 2, complementary, angle 2 and angle 3, complementary. Step 1, that's my given. If you have a given, you need to write it out. You will always have a given, not if. You need to write out your given. All right. So let's just start here. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. And the measure of angle 3 plus the measure of angle 2 equals 90 degrees. We said that, we need to move this over a little bit, is just the definition of complementary, right? Sum of two angles equals 90. And what do we want to do next? I want to get my reflexive in here. The measure of angle 2 equals the measure of angle 2. Step 3 is, that's our reflexive property, and this time it's of equality. All right, what do we want to do for step number 4? I think that I want to use this right here. I am going to say the measure of angle 1 plus the measure of angle 2 equals, and check it out, the measure of angle 3 plus the measure of angle 2. And what lets me do that? Is that just substitution, or is that transitive? This one, even though we're using numbers, is more of a transitive property of equality, because they're equal signs, not congruence. This is a transitive because we have two separate ideas that are equal to 90 degrees. We're not just simply substituting in, x equals 6 and substituting in a 6. So now what am I going to do next? Hopefully you saw this when we were working over here. This has been a common theme for us. So step 5, I'm going to be able to say the measure of angle 1 equals the measure of angle 3 by the subtraction property of equality. And what was it that I wanted to prove? That my angles are congruent. Well, how do I get from equals to congruent? Step 6, angle 1 is congruent to angle 3, because why? We went from equal measure to congruent. That's just the definition of congruent. All right, well, that took a while. That would have been something that we should have written up here in our ideal section, because we are dealing with measures here, and we know we need to get to congruence. So definition of congruence is most definitely going to be used. All right, hopefully this helped with the proofs. Like I said, I promise you, you will get better at this. You will start to see these, you will start to understand them. You just have to think and do your setup, do your IDE before you act and try to write the proof. The more you work over in the setup and looking at the diagrams and marking things and writing down possible definitions, postulates, and theorems that you might use, the better you will be at these. All right, I am certain that you will do very well on the test, and good luck.